Hello ladies and gentlemen. Today I'm here to tell you about prisms. Now we've talked about length and one dimension. We've talked about area in 2 dimensions. Today we're doing volume, and that is 3 dimensions. Prisms, ladies and gents, are very cool. Mr. Savage.
Hey Mr. Wilkie, how it going?
Very good.
What are we doing?
Just telling these guys just how cool prisms are.
Prisms are cool.
Prisms are cool.
So I must be a prism, hey?
Mr. Savage, you are many things, but a prism you are not.
Oh.
No, a prism has to be exactly the same shape on the top as well as on the bottom. Must have straight edges, and they must be 90 degrees with the base or with the top. So I'm afraid, looking at you, you don't cut it. You don't cut it.
Not quite.
This, however, a beautiful example of a rectangular prism.
Yeah, definitely.
Do you think this one's a prism?
Yep, checks out.
Sure does. Top and bottom the same, straight edges, 90 degrees with the bottom. We are definitely talking a prism.
Awesome.
Do you know how to work out the volume of a prism?
Volume of a prism. So I know if we have the area, we're halfway there.
We are, exactly.
Is that right?
That is exactly right.
But when we're talking area, we're talking a flat 2-dimensional shape. So we also need to consider the height or depth of these 3-dimensional shapes.
Exactly right. So if we know the area of the base, we just need to multiply that by the height, and that gives us the volume of any prism we've got.
Fantastic.
Absolutely.
So the equation, if I had to write up the equation, would be volume equals area times height?
Absolutely it would.
Let's do it.
Fantastic stuff. Now you'll notice that a shape like this, what is the shape of that base there?
That is a rectangle.
Absolutely. And can you remember how to work out the area of that rectangle?
Of course I can. Length times width.
I was really hoping you'd get that one right. You're right. So instead of area for this particular prism, for any rectangular prism, we could actually just write volume equals length times width times height.
Okay.
Works out very well because there's 3 dimensions to this shape. Fantastic. Now it just so happens the length of this one here is 50 centimetres.
Okay.
The width is 20 and the height is 40 centimetres.
Okay.
Do you think you'd be able to work out the volume for that?
50, 20 and 40.
You've got it.
Let's have a go.
Let's do it.
So, the length was 50 centimetres. The width was 40.
20 centimetres?
The length was 20 centimetres.
Absolutely it was.
And the height was 40.
That's true.
Okay. So I'm multiplying 3 numbers, both have 2 digits with 0. I'm going to use my little shortcut here. 5 times 2 gives 10, times 4 gives 40. And then I had 3 additional zeros, which I bring down as well. And did you say it was centimetres?
I absolutely did say centimetres.
So just centimetres down here?
Well, it turns out that if we're just measuring a length, it would be centimetres. An area would be centimetres squared because it's got 2 dimensions. Volume, because it's got 3 dimensions, is actually centimetres cubed.
Makes sense.
Sure does. So Mr. Savage, this particular shape here has got the length, the width and the height all the same because it's a cube.
Right, yeah.
How do you think you'd work out the volume for that one?
Well, I'd probably look back to the original equation we talked about, volume equals area times height. If we could work out the area of the base of the prism and multiply by its height, we should still get the volume.
So Mr. Savage, would you mind working out the volume for this cube for us?
No worries.
Given that each of those side lengths are 40 centimetres.
40, 40, 40. Okay, so back to the length times width times height equation. I'm going to substitute in 40 for each of those numbers. Times 40 times 40. 4 by 4 gives 16, times 4 gives 64. And then I had 3 zeros to bring down as well. Centimetres cubed.
That's fantastic. So it doesn't matter which of these prisms we look at. If we're talking a rectangular prism or a cube, it's still length times width times height. What about if it wasn't a rectangular prism? What about if it was something like a triangular based prism?
Okay.
How would you work that out?
I'd probably go back to that original equation, volume equals area times height. I'd find out the area of the base of that shape and then multiply by height.
Sure. So we really need a shape to work on, don't we?
Yeah.
Okay. So if we're talking a triangular prism, we're talking about probably half one of these.
Yeah.
We probably need something to cut this in half.
Have you got anything?
As a matter of fact, I have. I bought this just in case.
Whoa.
Just in case. So, we're going to try and cut this one in half, right?
Okay, let's do it.
All right. Let's see what we've been left with.
Yeah.
All right, so Mr. Savage, now we've cut that thing in half. That means really to work out the volume of a triangular-based prism, we're just going to do half of a rectangular prism.
Right, that makes sense.
Okay, so rule-wise, what does that mean you're going to put down?
Well, we could just write half a volume, but if we hadn't solved for that volume already, we'd probably want to be halving something else. And I recall that the area of a triangle is half the base times the height.
Ah, so exactly like a rectangle, we go length times width, but then you divide it by 2.
Exactly.
Gotcha.
So if we put that multiplied by a half into our equation as part of the area, we should solve the volume.
Fantastic. Let's see.
So we go half times the length times the width times the height.
That's fantastic. And this one was still length of 40, width of 40, and a height also of 40 centimetres. Super stuff.
So that would solve to 32,000.
Absolutely, which is exactly half of the cube that we had up here before of the similar dimensions 40 by 40 by 40. So to sum up, to work out the volume of any prism, all you're really doing is the area of the base multiplied by the height. If it's a rectangular prism specifically, we're talking about length times width times height. And sir, a triangular based prism?
Half length times width times height.
Welcome to the world of prisms. All right. Let's see what we've been left with.